It's really a pleasure to be here at Ohio State University. I find it very fitting and appropriate that this data is presented here for the first time, because when I was curator of astronomy in the museum field back in Springfield, I remember reading one day in Sky and Telescope an article about a very pioneering radio astronomer who, against great odds, had set up a facility not too far from here out of spare parts and baling wire and in the middle of a cow pasture, and ultimately wound up conducting some of the first serious SETI research, the search for extraterrestrial intelligence by means of radio, the ET will phone Ohio State University model. And it never dawned on me then that I would be standing on a stage at OSU to present to you some pretty interesting photographs, not of ETs phoning us, but of possible structures very close at hand that we can get back to almost day after tomorrow if we so choose. I've never done this before. This is the first time this data will have been presented. We've been working on this for about a year and a half, very quietly. It began almost by accident, as I will describe. And as we move closer to a position where we could actually present this to an audience somewhere, there were lots of possibilities. We're in discussion with some folks in the administration. There have been discussions of bringing us to Washington to brief some of the Clinton administration people on what we have found. The time frame did not quite fit other schedules. So it fell by default, and a very wonderful default, I think, that we're going to unveil this information and these pictures, which are our pictures. We bought and paid for these pictures. And somehow, you and I have not gotten to see what's on these pictures for over 30 years. And it's high time that we did. And then we have some decisions to make about what we do about what's on these pictures, because the implications, both cosmologically and politically, are not trivial. So when it came time to do this, I realized that there could be no more fitting thing to do than to unveil this data before not political people, not media people, but real people. And as some in New York call this, the heartland of America. So here we are at OSU. I'm very glad you're here. I'm glad to be here. And let's begin. I want to set the scene appropriately, because just before this nation physically sent men to the moon for the first time, a friend of mine, who became a friend of mine in subsequent years, and who sent me a very nice letter the other day, acknowledging that there finally, from his point of view, may be something in the Mars data after all, and I've now got his curiosity. Mr. Arthur C. Clarke debuted his stunning film, 2001. A couple days ago, Arthur wrote me this wonderful note acknowledging that the Mars data seems to be intriguing enough to be pursued. And I wanted to start tonight, because we've titled this presentation 2001 Revisited, with a short reprise of what Arthur's claim to fame in the hearts of most Americans has been. Because in 1968, a few months before the first intrepid men of Apollo 8 went to the moon for the first time, Arthur's film, 2001, which he and Stanley Kubrick co-wrote, debuted, premiered in Los Angeles and New York. And for those who don't remember the premise or may not have seen the film, and is there anyone who has not seen this very interesting film? Let me just encapsulate what it is about. What it is about is that as part of space activities, the officialdom, the equivalent of NASA in the next century, finds an artifact on the moon as part of its manned missions. It then decides, because of social, political, philosophical, and religious implications, to withhold that information. Only months later, with 1960s technology and 3 intrepid men, Borman, Lovell, and Anders, the beginnings of a saga like that began. It lasted through 12 astronauts and not too many years. This is now the final mission, the Endeavour mission of Apollo 17. All too briefly, our foray to the moon, our exploring the unknown with people like Gene Cernan and Harrison Schmitt, was over, almost before it had begun, almost before we could turn around this nation which began a journey that was to last into infinity, suddenly stopped going.
Coming in. There it is, proceeded. And there it is, Houston, there's Camelot. Wide off target. I see it. We got them all. 42 degrees, 37 degrees, to 5,500. Stand by for some dust. Little forward, G. Pivot forward a little. 90 feet. Little forward velocity. 80 feet. Going down at 3. A little dust. Going down about 2. Very little dust. Very little dust. 40 feet, going down at 3. Stand by for touchdown. Stand by. 25 feet, down at 2. Feels good. 20 feet. Going down at 2. 10 feet. Contact. Push. Engine stop. Okay, Houston, the Challenger has landed. Roger, Challenger, that's super. Houston, you can tell America that Challenger is at Taurus Littrow.
And on our television screens, for all those journeys, as the technology got very much better in a very short period of time, we saw live views of the moon. Pans of landscapes like this, pans that became so familiar that you can't turn on a commercial or see an historical clip or even watch late night television without seeing some frame that was taken during the Apollo missions to and from the moon. It has given us the impression that we know the moon like the back of our hand. It turns out that is only an impression. Because what we have now been looking at are photographs, data returned from several different types of missions over several different years, from 1966 through 1972. The Surveyor, the Lunar Orbiter, and the Apollo missions. And on each of these separate technologies, with different lighting, different geometry, different technologies themselves, we have found and corroborated what we're going to show you in the next few hours. We have found, apparently, the real moon, the moon that perhaps only a few inside NASA have ever really seen. Have you ever wondered why in fact it is a quarter of a century this week since Apollo 10 went to the moon, we haven't been back? Have you wondered why the only return mission in all that time was a military mission lofted a few months ago by the Pentagon? And why you've heard almost nothing about it? Hopefully, what I'm going to show you this evening will put some new perspective on those questions. This is the plaque that was left on the landing legs of the lunar module Challenger to companion with Neil Armstrong's plaque. And then from the rover camera, the lunar module ignited, rose into the black sky, and the last men in the Apollo missions to visit the moon came home. Behind them, on the surface, scattered at places like Hadley Rill, Frau Morrow, Tranquility Base, Taurus Littrow. There were debris, technology, bits and pieces, trinkets left by the brief human exploration that was Apollo. Rovers, backpacks, antennae, trash bags, all the debris that humans have developed on our own world brought fleetingly to the surface of another world 250,000 miles away to remain for millions of years until it is degraded. Oh yes, and it must not be forgot that we've left one more thing: Six Flags. The flag of the nation which accomplished this extraordinary miracle sent 12 men where no one had gone ever before in all of recorded or unrecorded time, brought them all safely home, and then stayed home. It is so close and yet so far. It's 240,000 miles away, orbits roughly once every month, turns the same side toward the Earth all the time, so there's an Earth side and a far side, and we see roughly 60% of the moon, and the other 40% remains dark, never to be seen by the eyes of earthbound man or woman. In the late 1950s, 1958 to be exact, we, as a government, politically put together, under the leadership of President Eisenhower, a very unique agency in the history of the federal government, the National Aeronautics and Space Administration. This is part of the NASA Charter, which, among other things, mandates that the widest appropriate dissemination of the data gathered by NASA's activities be presented to the American people and through them to the rest of the world. This was an extraordinary achievement for government in the late 50s, because if you remember what was going on, if you remember from reading the history text, what you will note is that there was intense inter-service rivalry between the military services, Army, Navy, Marines, for who was going to control and be lead agency in the new fledgling ocean of space. It took a military man, President Eisenhower, to decide very wisely that instead of giving space to the Pentagon, space should be reserved to the civilian side. Space should be reserved to the citizens of the United States themselves. And that everything that was done under the aegis of this new civilian space agency should be open, above board, and freely available to one and all. On behalf of that charter, NASA has established, early on, a series of archives around the country. The most prominent archive, where we have now been able to obtain the photographs you're going to see in a few minutes, is the National Space Science Data Center located just outside Washington, D.C. What I'm going to show are images that we have secured through the National Space Science Data Center. We have analyzed, we have subjected to intensive computer image processing techniques and technology that literally was unavailable almost anywhere when these photographs were acquired over a quarter of a century ago. And these photographs are available to you. What I'm going to do is to give out the frame numbers so that you and others that may be hearing or seeing this will be able to go to either that archive or other NASA archives and extract the same data and make the crucial, pivotal comparisons to verify what we believe we found. There is a problem, however, because as a backdrop, behind the scenes, as those fine words were being written and the charter of NASA was being signed, there was a document, there was a study commissioned by NASA of a group of prestigious Americans from all walks of life: academia, politics, law, economics, etc. It is called Proposed Studies on the Implications of Peaceful Space Activities for Human Affairs. It was prepared by the Brookings Institution in Washington as a report to NASA, and subsequently was communicated on April 18, 1961, by NASA to the U.S. Congress Committee on Science and Astronautics of the House of Representatives of the 87th Congress First Session. It is also available in every federal archive, of which there are many. We found this copy in, kind of ironically, Little Rock, Arkansas. What's important about the Brookings Report, as we term it, is what you read on page 215. Because on page 215, there is the beginnings of an interesting discussion titled Implications of a Discovery of Extraterrestrial Life. Now keep in mind that NASA had literally been born, breath breathed into it by an act of Congress in July of '58, as an agency designed to be the most wide open and accessible in the history of the United States. In this study, where people of the caliber of Margaret Mead, the president of MIT, the Legal Affairs Council for the UN, on and on and on, prestigious men and women, one and all, who met over a period of a year and considered every possible impact of NASA's activities on human affairs, ranging from sociological to economic to geopolitical. On page 215, the document says, and I quote, "Artifacts left at some point in time by these life forms," meaning life forms to be found somewhere in the solar system, "might possibly be discovered through our space activities on the Moon, Mars, or Venus." Forecasting ahead 10, 20, 30 years, it was considered absolutely the norm then to expect that maybe, just maybe, as part of its ongoing activities, sending unmanned robotic probes throughout the solar system, which was NASA's plan, then subsequently carried out brilliantly, successfully, in what has now been termed the golden age of planetary exploration, that some of those probes might, in fact, one day trip over an artifact left by someone else. The document then goes on at the bottom of this page to discuss what might happen. It says, "Anthropological files contain many examples of societies sure of their place in the universe which have disintegrated when they had to associate with previously unfamiliar societies expounding different ideas and different life ways. Others that survived such an experience usually did so by paying the price of changes in values and attitudes and behavior." What the document was warning was that if NASA were to discover extraterrestrials or even their artifacts, the social consequences conceivably could lead to the, quote, "disintegration of civilization." Now, it's important that you keep this document, this official NASA study, in the back of your mind as we go through the rest of the evening. Because what we have here is a political and social and logical paradox, a contradiction. On the one hand, we have formed an agency which is supposed to be the most open, the most candid, the most honest, the most ethical, the most inquisitive on behalf of all Americans in the history of the Republic. And on the other hand, we have set out a blueprint that in one area, one important, crucial area, that it may find data. It may, in fact, find data that contains within it the seeds of the destruction of the Republic itself. And what you have to ask, and what I'm going to show happened at the end of the evening, is what apparently was done with this logical paradox, stretching now across decade after decade after decade. Because as you see this data, and you ask yourself what I've asked myself over and over and over again, having been a member of, the media, having sat at the right hand of Walter Cronkite, which is one step below, the right hand of the other guy, having been in NASA and outside of NASA, having seen thousands of pictures, having experienced, lived through the most incredible adventure and journey in the history of mankind, as I began to find what we're going to look at, I had to ask myself over and over and over again, Hoagland, are you crazy? How could anyone have missed this? And the answer, I believe, will be found in this document. So I'm going to save the ending of the document, what the recommendations of Brookings to NASA back in 1959 were if NASA were to discover extraterrestrial artifacts, and proceed on with the story of how we got involved. Because our entry into this saga, this unfolding adventure, was relatively late. It wasn't until about 1983 that I became intrigued with this object, which, by the way, fits the parameters of the Brookings study. This could well be an artifact discovered by NASA, by Viking, in the course of its expanding unmanned exploration of the solar system, which could well indicate that somehow, somewhere, in some time, someone came before. Nothing unscientific, nothing outrageous, nothing strange, because NASA's own studies had predicted that we might find ourselves in this situation. Well, from my beginning naive involvement with asking and trying to answer the question, is this a real artifact? What happened was I wound up setting up several subsequent investigations, ranging from the independent Mars investigation to the Mars investigation group to now the Mars mission, all in an effort to inveigle scientists away from their day jobs to pursue something that may be a tad more important in the long run, namely verification that the human race is not alone. Because as we looked at the official treatment of the Viking data, there was a brilliant and blinding denial of the possibility that this information could be real or have any significance. Well, in the course of the last decade plus, not only have we, to the best of our ability, believe we have confirmed the reality of the so-called monuments of Mars, we have found a stunning geometry which links these structures around the face, which includes pyramids and other unusual morphological shapes and forms. We have found that there appears to be a mathematics encoded in this geometry, which if you were asked to reduce it to one important symbol, it would be this. In 2 dimensions, it would be an equilateral triangle. In 3 dimensions, something called a tetrahedron. And as we go through the evening, I will explain why this symbology is very, very important in decoding not only the monuments of Mars, but in now demonstrating and possibly proving a connection between Mars and the moon. Because if you look at the logic of an alien civilization on another planet, creating its own structures, or trying to send messages to others that might inhabit the night and might come its way someday, what you find is that there is only one basic intralingua, one basic common language that we and they would ever have in common. And it is the language of science. It's the language of physics, the language of chemistry, the language of basic Euclidean geometry on a small scale, the language of science itself. So in retrospect, it is not all bizarre that we should have been successful in decoding the meaning of the monuments, because the geometry which we have found over and over and over again redundantly is telling us that whoever did that was trying to communicate the same fundamental constants by which our own lives and our own technology are ruled today. And therefore, we do have something in common, and we can figure it out. Well, these aren't new ideas. It turns out that in the last century, the giants of science, people like Carl Friedrich Gauss and Lockyer and even Lowell, were thinking and writing and proposing the same ideas. Except for them, they were imagining if they were, quote, Martians looking at the Earth, and they were trying to devise, in the Victorian rising idiom of science, some kind of means of signaling the presence of Earthmen. It was a Victorian era, of course. Earthmen out to the universe, out to whoever would be looking, at Earth with Victorian-type telescopes. And what did they propose? They proposed creating things like this: huge Pythagorean theorems and geometric figures and triangles in the deserts of the Sahara, digging them with bulldozers and lighting them with flaming oil so they could be seen at night by Martians peering through telescopes millions of miles away, looking at the night side of the world. There was another group that proposed planting fir trees in huge geometric symbols on the steppes of Siberia to accomplish the same end. But the thing that links those ideas with what we have discovered in the monuments of Mars is simple: geometry. The common geometry of conscious beings inhabiting the same universe, operating by the same physics and by the same laws, and looking out at the same phenomenon. Well, this whole story, here's the commercial, is encoded in another language, English, in this book, which is now in its 9th or 10th printing, I forget which we updated in 1992. It's called The Monuments of Mars, and it contains basically a narrative of everything we have learned up to this evening. You will not find this evening within those covers. However, there's another book that I want to bring to your attention, and it's this book. This was a document which was handed to NASA literally on the eve of Mars observers' disappearance last year. It is an intensive report conducted by Professor Stan McDaniel, former chairman of the philosophy department of Sonoma State University, an epistemologist, an ethicist, an historian of science, who began naively wondering why NASA had not targeted Mars Observer to photograph and either falsify or verify the monuments of Mars. And what began as a very naive question extended for about a year and a half of his life and wound up being a 200-plus page report with 300 to 400 meticulous footnotes and references, all attesting to the fact that NASA, on the Viking data, vis-a-vis Cydonia, vis-a-vis the so-called monuments of Mars, vis-a-vis the face, has been doing everything but science. And for us to say it, who obviously have a vested interest, is one thing. But when an independent referee comes in, sight unseen, examines the field, commits a year and a half of his life to trying to write what he views, in his own words, as the potential for the most egregious crime in the history of science, and said document is then delivered to NASA, to the program scientist, Dr. Bevan French, for the Mars Observer Project, and 36 hours later, the Mars Observer spacecraft simply disappears. One does begin to wonder if there is a problem. And if the problem goes back to this document, the Brookings document, which warned that finding artifacts or intelligence out there might conceivably endanger the future of civilization. Well, one of the things that McDaniel did in his report was to verify that our methodology seems to be pretty sound. We seem to be asking the right questions. We seem to be arriving at provisional answers through the appropriate mainstream methodologies of science. It's the kind of thing that obviously we could not have created. We had to wait for Stan McDaniel to basically put his shoulder to the wheel and do the independent work and discover that we, in fact, are doing what we should. Part of what we have been trying to do is to decode the meaning of the geometry, the meaning of the math involved in the relationships between those monuments. And one of the funny things that we have found, one of the absolutely unexpected things that we now think we have discovered and we're dying to get on with figuring out, is the possibility of a whole new physics decoded in this geometry and math. A physics which can successfully do everything from predict the latitudes of the major active centers on the sun. That string of brilliant lights in the northern and southern hemisphere of the sun, which are plages in the chromosphere and intensely heated regions in the corona just above the surface of the sun, shown in this false color X-ray view, those group along two key latitudes, which you're going to hear some more of later on this evening, 19.5 degrees north and south. As we pursued this idea of a physics, one of the things that came up over and over again was that the math and geometry between these objects on Mars was capable of predicting the positions of the most active energetic upwellings in planets all across the solar system. In 1989, when the Voyager 2 mission flew by Neptune, a couple weeks before the encounter, before we had photographs this stunning, before the actual determination of the latitude of the great dark spot of Neptune had been accomplished, one of my colleagues in our project, Errol Torin at Defense Mapping, and I published a paper electronically on the CompuServe Information Network. And we did it deliberately because we wanted to have on the record, before NASA announced it, our prediction of the latitude of the great dark spot and the magnetic polarity of Neptune based on our provisional understanding of this physics that we believed we were decoding. And we were successful. The great dark spot is at 19.5 south. And the magnetic field of Neptune is opposite the Earth's, although to a greater extent than we had thought at the time. What is important is that this is part of a trend. The great red spot, this vast vortex which is swirling around and around and around in the southern hemisphere of Jupiter, the great red spot, like the great dark spot on Neptune, the great red spot of Jupiter is, you guessed it, at 19.5 south. And we now believe we understand, because it seems that these huge cyclonic upwellings are part of an energy system contained within the planet which is obeying these new laws that we believe we're in the process of decoding and understanding and exploring. And the positioning of these vast vortices in a coordinate system which is tetrahedral. That is, if you put a tetrahedron in a sphere, where the points touch the sphere is where the energy upwellings will come up. And so far, we have not found an exception across the entire solar system to this prediction. And if you know anything about the Popperian model for science, you know that science is nothing if it's not specific numerical prediction. Well, we were able to extend the predictions to Io. Let's go back one. You notice there are two little glowing dots, one here and one over here. This is Europa, one of the inner moons of Jupiter, and this is Io. They're both about the size of Earth's moon. Now, Jupiter, on the other hand, is something like 10 times the size of Earth, 1,300 times the volume of the Earth. So these little moons are really, on this scale, moonlets, little grains of sand orbiting a giant, as opposed to our own moon, which we'll get to. I promise you, we will get to our own moon. Why is this important? Because on Io, signified by these brilliant bluish plumes, which are caused by little tiny particles scattering sunlight so that the plumes of volcanic emission appear blue for the same reason that the sky appears blue, because of what's called Rayleigh scattering of light. What Voyager found as it flew by in both the Voyager 1 and Voyager 2 mission is that Io has a series of intense volcanic emissions. 7 or 8 active volcanoes. Volcanoes that are so dramatic and so active and so violent compared to terrestrial standards that Io definitely contains the most violent geophysical, or is it iophysical, activity of any body in the solar system. Now, there is a standard model which says that this is caused by tides from Jupiter. Well, that's nice, but guess what? That model, which is the mainstream NASA model, cannot explain why the volcanoes are arranged on Io in terms of latitudes that conform to higher levels of the tetrahedral geometry and math. And our proposal, our explanation, very simply, can. A segue for the placement of these geophysical processes is the fact that on Io, there is a lot of energy coming up in a very violent fashion. One of the implications of the pursuit of this new physics is that we have discovered a virtually unlimited, pollutionless energy resource, if you can find a way to harness it. The energy is coming, and I'm not going to describe the details of this because you can see it if you look at the UN briefing, or you can see it if you read the book. But the energy now appears to be coming from a higher dimensional set of space, n spaces. That is, n-dimensional sets, 4 space, 5 space, 6, and above, which are co-sharing this room with us even now, but are invisible because literally they are in another dimension. What the physics seems to be showing us is that there is a mechanism, a natural mechanism in our familiar three-dimensional existence for tapping higher energy realms of hyperdimensional physics. And if you can tap those, if you can provide a conduit so that the energy will cascade downhill, heat flows from hot to cold, it never goes from cold to hot. If you can set up the proper conditions so the energy flows into our familiar three dimensions, what you discover is that worlds such as Little Io will literally turn themselves inside out in a few million years, spewing prodigious amounts of energy into space over and over and over again. Jupiter, Saturn, Uranus, and Neptune, the 4 giant planets of the solar system, have been known since the 1960s to all be radiating more energy out than they are getting from any known or modeled source. Jupiter is radiating about 1.7 times more energy, Saturn about 1.8, Uranus about 1.2, and Neptune a whopping 2.7 to 3 times more energy coming out than is flowing in from the sun itself. And you can't get around it by saying, oh, there's radioactive stuff going on in there, or oh, the planet is shrinking, or oh, the helium is dripping, or any of the models that are out there, because it turns out when you look at the numbers that those models simply don't really work. As Ross Perot has said, and I'm going to repeat a couple times tonight as I show you the details, the devil is in the details, because it's the details that allow you to discriminate between various ideas, various models. So what are we left with? We are left with a physics that apparently is successfully able to predict planetary activity, the locations of phenomenon on the surface of these spinning worlds, ranging all the way from the placement of sunspots and solar activity on the sun, all the way out to the last planet currently in the solar system, the planet Neptune. Now that is a pretty amazing track record for a theory derived from a set of objects on a planet that should not exist. Because remember, this all came from our decoding of possible artifacts on the surface of the planet Mars. Now the neat part about this is that it's all checkable, it's all testable, it's all verifiable. All one has to do is be willing to cast your prejudices aside, to stand back in a little humility and a little awe, and simply begin to do the homework. For 18 years, since NASA took the photographs of the monuments of Mars, NASA has not publicly done any of the homework. That has fallen to a small but growing team of outside researchers who have tried to pursue good science while both metaphorically and in some cases otherwise being shot at. Which brings us to the moon. The Earth-Moon system is unique. My late friend Isaac Asimov has called this a double planet system. The reason is that the Earth, roughly 8,000 miles across, is orbited once a month by an object that is roughly 2,000 miles across, roughly 1/4 of its size. Remember the ratio of Jupiter and Saturn and the larger planets and their moons is grains of sand orbiting huge beach balls. So the first thing we start out with in looking at the moon is its uniqueness in terms of its size relative to its primary, relative to planet Earth. But things quickly get more interesting. As we begin to look at the moon, one of the first things you have to remember, of course, is that you're only going to see this side. This is the Earth side. There is, by the way, no dark side. I don't know where that ever got started. Every spot on the surface goes dark for 2 weeks because you have 2 weeks of day and 2 weeks of night. This day-night period is the day of the moon and is equivalent to its year, which is the time it takes for it to go around the Earth once, which is roughly 1 Earth month. So there are 13 moon months in an Earth year, et cetera, et cetera, et cetera. So this will give you some feeling for what we're dealing with. Now, from time immemorial, as men and women were looking at the moon and gazing at it with the naked eye and then with telescopes, which brought it closer and closer and closer, one of the things that has struck everyone is that the moon appears to be divided into 2 main regions, the dark stuff and the light stuff. Galileo thought the dark stuff were seas, oceans, ergo the Latin term for these dark areas, mare, meaning seas. But they're not seas the likes of which we've ever known on Earth. They're waterless, they're airless, and we'll get into the details on that in a few moments. The light things, the light areas, are called highlands, or terra. Terra meaning land in Latin. Well, as you continue to move closer, as you focus in on the very center of the lunar disk, one of the kind of interesting things that you will notice is that the moon has now had visitors, including the Pentagon. This is the Clementine mission, which took over exploration of the moon a few months ago and then also mysteriously vanished. We'll get to that in a little while. But for the first time in 23 years, the only object to go back to the moon that we know of from this country was this little 500-pound satellite put together by the Naval Research Laboratory, instruments built by the Brookhaven National Laboratory, with consultancy by a small group of NASA scientists for the photography. As we continue to move in, looking at the moon, one of the things that you will notice in this central region, which is called Sinus Midi, which means Central Bay, one of the things you'll notice is that there appears to be an 18-mile crater called Oort. And in Oort, in the middle of the moon, if you were standing in Oort at the right moment and looking directly overhead, there would be the Earth. At the closest point on the moon to Earth, there is a crater with an equilateral triangle marking its interior. The symbol we have decoded from the monuments of Mars. It was this symbol which basically focused our attention on this region. Because in the idiom that someone has been in the solar system long before, that someone has left a series of monuments or structures or artifacts designed to tell us something of their presence, of their history, of perchance their discoveries, their knowledge base, their achievements, perhaps to help us to achieve similar achievements. This is an amazing discovery. I mean, we've looked now at an awful lot of craters, and this is the only crater that I have been able to find that has a perfect equilateral triangle in the surface. Now, this is an Earth shot. This is from the Yerkes Observatory. This is what astronomers should have seen and have wondered about in the Gaussian model of intelligence will put geometry on other worlds. And notice this. On the rims of the crater, spaced 120 degrees around from the vertices of the inscribed triangle, there's a bright region, a bright region, a bright region. So what we have are two interlocked tetrahedra, here and here, if you think of this as a three-dimensional construct, which of course a two-dimensional equilateral triangle can become if you do a dimensional rotation. That was how it began. What we then began to do was to try to acquire photography taken by various space missions around the Oort region on the theory, on the model, that someone at some point in the space program may have photographed something important and significant, artificial, in this region of the moon. It was nothing more and nothing less. Now, it's really unusual and odd and wondrous that the crater we found with this symbol is the crater that, under certain times of the month, is literally right under the sub-Earth point. And you can look directly overhead and see the Earth as a 2-degree spinning sphere. So what we began to do was to look at a series of NASA data. There were 3 missions that I was focusing on. One was data collected by this spacecraft. This is the Lunar Orbiter series. I'll describe the technology of Lunar Orbiter in some detail in a couple of minutes. It photographed the moon from the mid-1966 to late 1967. It actually took film to the moon and scanned the film and then read it back to Earth. Then there was Surveyor. This is Alan Bean standing next to Surveyor. This gives you an example of the scale. Surveyor was our first successful unmanned spacecraft to land on another world. It stood about the height of a man. It contained one very important television camera, which looked out about the height of a man and scanned the horizon and the sky and the ground. It carried a sample arm to dig trenches. It carried retro rockets to land softly, electronic boxes, solar panels, high-gain antenna. It was our first robot explorer from the surface of another world. And on Apollo 12, the second Apollo mission, NASA directed the lunar module to land near Surveyor to bring back pieces for analysis of what would happen to terrestrial materials exposed for 31 months to the lunar environment. And then, of course, there was Apollo itself. Apollo, which was a remarkable achievement in the history of mankind. More men and women focused in a brief period of time on a single project of unimaginable scope, successfully achieving it, and all without firing a shot. What I want to do for a moment here is to take you back in time. I want to show you the world on which you live. We take the Earth for granted. In going to the moon, it turns out that you can't take anything for granted. The processes that are available here on our world, as it spins and spins and spins, are not found on many other worlds. In fact, from NASA's probing and photography and detailed investigations, the kinds of processes we see on Earth that we take for granted, clouds and wind, and the sculpturing of the erosive atmospheric processes that lay our deserts and sculpt terrain, these are pretty much unique to Earth, with one possible exception of the planet Mars. Photographed from space, the deserts look banal and featureless, revealing little from orbit of the majesty, of the wondrous activity that has gone into shaping these very tortured landscapes. Literally millions, if not billions of years of terrestrial planetary history laid bare by the successive erosive forces of wind and water and erosion, cutting away sediments, cutting away volcanic lava fields, cutting away the layerings of rock, while the planet rotates on and on and on. A brief twinkling of planetary time. The Anasazi were born and disappeared in 1,000 years, a brief blink against the time that we find on other worlds. airless, barren, cratered, silent, desolate, waiting for the first human footprints that would betoken that we finally had left our mother world and journeyed to the moon. So let's recapitulate. The Earth has what the moon does not. It has water, air, clouds, sedimentation, which is basically mountain building out of sediments, and it has active mountain building, volcanoes building up huge piles of lava, igneous rock, etc., etc. What the moon looks like, because it does not have these processes, is what you see here. This is a photograph montage taken by Apollo 10 looking over Sinus Medi. This is Okhurt up here. This is Tri-Snecker. These are two craters called Bruce and Blagg. This is the region of the Central Bay in here. Notice it's dark compared to the bright highland terrain over here. It has been sculpted by very different processes. For one thing, there's an awful lot of empty space on the moon. The moon is 15 million square miles. That's the equivalent of North and South America combined, or the entire continent of Africa. And we've been there 6 times with 12 human beings, and we ranged 3 or 4 miles from the lunar module. Can anyone with any reasonable perspective say that we have really, really explored the moon, an entire world of millions of square miles of real estate, of landscapes, of unfamiliar terrain? The other thing the moon has, which the Earth of course does not, is an incessant meteor bombardment. Look at these hills. These are the hills that frame the Taurus Littrow Valley, where Apollo 17 in December of 1972 touched down. Notice their shape. They're rounded and sculptured. There was a John Wayne film many years ago called The Sculptured Hills. The film should have been shot on the moon, because the hills on the moon are sculptured and have been sculptured for literally billions of years by one irresistible force and process: the constant bombardment by a meteoric rain. And here you can see that there is another component that is unshielded radiation. What meteors do not destroy, radiation, hard particles, atomic particles zipping along at almost the speed of light, within tenths of a fraction of a percent of the speed of light, will destroy over time. If we need any examples, all we have to do is look at other bodies that NASA photography has now shown us in the solar system. This is the asteroid Ida, which was photographed by the Galileo spacecraft en route to Jupiter a few months ago. As we close in, you can see that Ida has been exposed to an incessant bombardment of meteoric rain. Crater upon crater upon crater upon crater upon crater. Every time a little object hits, be it something the size of a grain of sand, or something the size of this auditorium, or something the size of Columbus, it is called a hypervelocity impact. The energy transmitted in the impact is on the order of nuclear explosion potential. At some masses and velocities, of course, we're all hearing now about Comet Shoemaker-Levy 9, one little chunk, 2.5 kilometers across, which is going to deliver into Jupiter something like 100 million megatons of collisional energy. Without an atmosphere, with no shielding, everything from little bits of sand all the way up to mountain-sized asteroids will collide and collide and have collided for unending time. One of the validations that the astronauts did in fact go to the moon, contrary to the weird stories that have been circulating for 25 years, and returned home with almost 1/2 ton of rocks, is to be found right here. This is a little glass bead measuring about 1/100 of an inch across. This little glass bead has on it a little glass bead crater, formed by a tiny particle, tinier than the pinpoint of a pencil, striking the surface of this little glass bead as it lay on the surface in the moon dust at a hypervelocity impact, 10, 20, 30 miles per second. At those speeds, something like 10 to 100 times the mass of the impacting particle is ejected in all directions, producing a bombardment which over time, as the astronauts attested from their landings and their comments and their orbital photography and their observations, the sculptured hills of the moon. Rounded, gentle surfaces beaten into submission by billions of years of unrelenting bombardment from cosmic space. It's very important. In fact, if there's one thing I want you to go away remembering, it is that process operating on the moon. Because under those conditions, which can be typified here in a diagram that we borrowed from a lunar science conference paper delivered several years ago, what you have is impact, debris transport, downhill, talus slopes, level plains. There is one-way entropic degradation going on the moon. There are no volcanoes. There are no active mountain building orogenic uplifts. There is no erosive rain. There's no hydrological cycle. There is one process, and one process now, today, this moment, tonight, going on the moon, and it is an incessant cosmic meteoric rain. Now, if I seem to be belaboring the point, I'm about to show you why what we have now found is so in violation of that fact, of that model, that it begs for an explanation. A real one, not a fake one. A real answer and an explanation. Because standing on the lunar surface, photographed by Lunar Orbiter 3 in February of 1967, extending 1.5 miles above the moon, there is a shard of something, casting a shadow out across the lunar surface. This is a resume mark on the photographic film. We'll get to the details of why that's important a little later on. The fact is that under the standard model of the moon, under the incessant bombardment which has cratered every object we have photographed all across the solar system, this object literally cannot exist. There's nothing to have formed it, and if some freak of nature had created it billions of years ago, when the astronauts' moon rocks tell us the last datable geological activity from within the moon took place, the billions of years of incessant bombardment should have obliterated it from the landscape. It should not be standing as a spire, a kind of a dumpy spire, 1.5 miles above the moon. Now, how do we know that it's 1.5 miles above the moon? This is where things will begin to get a little technical. So please hang with me. These are footprint maps from the Lunar Orbiter mission series. What you see here is basically the middle of the moon. This is the current sub-Earth point. Oort is right up here out of frame, all right? And what you see are maps showing the projected viewing angles of photographs taken by the Lunar Orbiter series during its, about 1.5 year mission of all of the spacecraft that flew from Orbiter 1 to Orbiter 5. What we've done here is to highlight the frame I'm going to show you, which is called Lunar Orbiter 3 84M. The M stands for a medium shot, the 84 stands for the frame number, the 3, Roman numeral 3, stands for the spacecraft that took the picture. It is looking in the southwest from roughly 30 miles above the surface of the moon. This is the geometry, all right? So what did it see? This is the actual photograph. Here's Bruce and Blagg, those two craters that we saw in the previous shot. The little framelets, because remember, this picture was composed of actual film shot in the spacecraft, scanned electronically, and radioed back to Earth where it was reconstructed on ground television equipment. What you see here is the curving horizon. You see the southwestern edge of Sinus Midii, and you see these two little craters which are about 5 miles across. As we zoom in, now here's the edge of Sinus Midii, here's the horizon. What you're going to see up there at the edge is what we're calling the shard. This is the geometry, all right? Here you have the spacecraft. Here you have the altitude above the moon. Here's the simple geometry. Here's the equation that allows you to reconstruct the distance. It turns out we're dealing with right triangles. When you do the proper math, the hypotenuse, that long side of this triangle, is 256 miles for a 30-mile altitude of Lunar Orbiter 3 above the surface of Sinus Midii. That means that the horizon is something less than 300 miles away, roughly from New York to Washington. Okay, here you can see the schematic of the Lunar Orbiter camera system. It actually contained film, a film made by Kodak called a bimat film, bi meaning two. So you had film, and then you had developer on this bimat, which came into a processor. It was snipped off. It then went up here. It was read out electronically, put on a take-up reel. It had two cameras that took photographs side by side, a 3-inch lens and a 24-inch lens. The resolution looking at the horizon of the 3-inch lens was on the order of maybe a football field or two. The resolution of the narrow-angle camera would be roughly 8 times better. 8 into 300 feet is what? All right? So, here we have the shard. Now, what in the world is this thing doing sticking up above the surface of the moon? I mean, look at this. These are splotches, by the way. These are little dropules of water on the film as it was being processed in zero-G. It's very easy to eliminate them from real objects. There it is sticking up above the moon. Well, as we began to look at it very closely, we began to notice that there appears to be structure inside. And if you notice here, there appears to be a regular geometric pattern of little boxes, little cubicles. And they appear to be eroded as if you had a kind of a crystalline surface which you had beaten and beaten and beaten to death with some kind of erosive mechanism, and it is whittled away. And in parts, you can actually look into the interior and see cubical regular divisions inside in the shadows. And if you look at the surface, there appear to be multiple layers of transparent material through which you are looking. Obviously, very, very un-lunar-like by any of the standards of the Apollo and other reportage that we've had over the last 30 years. Okay? Well, that drew our attention. Now, as you overexpose this film, and this is the surface, all right, you begin to notice a very funny thing. This, by the way, is a frame line. The frames run like that, and the scans were along the film like that. So it's important to note that this does not orient with the scan lines of the film, nor, this is a mark that I put on in our own processing. Don't worry about that. This is a little residue mark which was imprinted on the film before it left the Earth. There's a geometric array. There's another one way out over there, another one way up there. And by knowing the geometry of this array of little stars, if there had been any distortions in the reconstruction process back on the ground, NASA could have used this preset grid to reestablish the correct geometry of the photograph. That's why the little marks are put on the film, pre-exposed before the spacecraft leaves the ground. Okay? So, what's this? This is really strange. If you go back, you can see that this is too close. But here, there's just a kind of, it almost looks as if it was one of these, all right? Except there's this one. See the grid? 1, 2, 3, 4. See this grid? So, what is this? This is really kind of curious. So we did some enhancements. Now, what do I mean by enhancements? I mean, you take state-of-the-art computer scanning technology, You apply state-of-the-art computer imaging algorithms, and what you wind up with on a desk is more computer power, manipulations per second, and total storage than all of NASA had when these photographs were acquired. If you doubt me, ask your local computer expert, because I checked with two the other day just to make sure. What we have been able to do using the now democratized technology, all of NASA could not do when these pictures were taken. And that, in part, I believe, goes some of the way, not all the way, but some of the way toward explaining why we found what we found, and most of NASA is going to be catching up and coming up the curve behind us. Because if those in NASA knew, there have to be a very small number who have known, and the rest have not had the technology at their disposal to even begin until recently to do what with the images that I'm going to show you in the next few minutes. So what do? We contrast stretched, we ratioed, we did sharpening algorithms, we did things like unsharp masking, deconvolution. We applied all kinds of standard state-of-the-art techniques to these images that have not been touched by anybody in over 30 years. And what we find is that this weird little blob appears to extend down toward the surface, and all along the surface, instead of being razor sharp, like we have been led to believe the moon should be razor sharp. I mean, look, there's no air, there's no clouds, there's no scattering. All you have is rocks and hard, hard vacuum. So why, if this picture is in focus, which it is, why do we have a fuzzy horizon, and why do we have an object with a tail looking like a comet extending down toward that horizon? This is one of the cute tricks you can play with computers these days. You can turn grayscale into color scale. The human eye is a lot more sensitive to color than it is to black and white. So now you can see that there appears to be all along here a very peculiar geometric structure. Initially, it looks like a fence. It looks like there are irregular rhythmic indentations there, 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 there. There appears to be a 3D perspective to it. It appears to go off in depth. There appear to be cross lines coming down like that, and it appears to be very, very, very eaten away. The most resilient remaining object appears to be this funny-looking thing with this tail standing next to this shard sticking up on a surface that should have neither. Now, as we got better at the processing, as we began to really fine-tune the details of exposure and grayscale and gamma and all these tricks you can play with images, we developed some pretty interesting images, and you can now see that this light to dark to light is an artifact of the processing. It really should be light all the way down to the surface. Okay? You'll see this in every Process NASA image. It's standard for this kind of technology. But what's interesting is that this thing appears to have a 3D structure. You can see that there's alignment here, there's one here, and there's one here. It's almost like this thing was on a tripod. And then as you get near the top, there appears to be more alignments. There appears to be a central core, and up at the top there appears to be now very interesting internal geometry. Remember, we're dealing with an absolutely airless vacuum. There is nothing in space above the moon. You're looking at something that is at a minimum 250 miles away if it's at the horizon. And at that distance, if you do the proper calculation, this thing is standing up against the sky something like 5 or 6 miles above the moon. And it has geometry. When you play games with color, what you see is that there is a very interesting depth, an optical depth, The inner parts, which are the brightest, red is bright, yellow is less bright, greenish is less, violet and maroon is even less. In other words, the density of color, the brightness of color, the color of the color corresponds to a brightness of the light bouncing around in this thing. The brightest parts are not on the surface as you would expect if this was a piece of rock. They're inside. This is very consistent with the idea that we're looking at some kind of crystalline object, some kind of glass-like object, which, like a diamond, is trapping light inside and is brightest where the material is optically most dense and has the most reflective planes. Now that's interesting because that turns out to be the inner parts. Well, thinking of these planes as meteor bumpers or meteor shields, if this is a real structure, and if it has been eroded and eroded and eroded by constant meteoric bombardment over billions of years, then that's exactly what you would expect. Tall cubical structures extending 5 to 7 miles above the moon's surface, composed of some glass-like, highly reflective, highly scattering, highly light absorbent material, literally has no place on the moon as we were given. Now, for those who are going to say, aha, but you've only got this on one picture, Hoagland, it's probably just a defect. Hold on. This is now a close-up. This has been produced or processed by a new technique, a new image processing technique called fractal processing. I will not describe fractal processing, but it is literally the latest state of the art. It has been adopted by the U.S. Army for all their image processing. We are in discussion with the company that provided them with their software. They provided us with our software. If the Army trusts what they're seeing on their pictures, why should we not trust what we're seeing on our pictures? You see the logic here? Anyway, here we have a really remarkable object. I hope you understand how phenomenal and anomalous and bizarre and wondrous and magnificent and any other adjective I can come up with this thing is. This should not exist. This is a megacube, roughly a mile across, composed of smaller cubes which have been beaten to death by meteors. You can see lineal planes and fractures. You can see transparent material veiling other material. You can see that this is part of a larger structure with little bits of glass or something scattering light in a geometric pattern. You can see internal consistency. In other words, you're seeing something that by everything we think we know should not be there. But it is. And the closer you get, the more the detail you can extract. Now, we think that the ultimate resolution is just about reached here, although we could probably go another factor of 2 if we had enlarged the prints by a significant size change that we were unable to do simply because of physical processes in the focal length of the lens that was being used. But what we're seeing is a multiple scattering surface with light coming in, bouncing around. The sun, by the way, is almost directly behind the camera. This is direct bounce back, and I'm going to have a slide here momentarily to show you what we're talking about when we talk about multiple scattering, because the geometry of how light moves between the sun, the surface, and the camera in each of the technologies that we're using is very important to figuring this out. So, have I bored you with enough photographs of the cube sitting on top of the tower? All right, this is the final one. This now is the color of the fractal. You can see that there is geometry within geometry within geometry. There are planes in here reflecting light, scattering light. They are apparently very well preserved, as you would expect if they were in the middle of a structure which has protected them from meteor bombardment because they're at the center. This thing must have been much larger, and it must have been whittled away by erosion and erosion and erosion. And on the moon, the only erosive process is that incessant meteoric rain. hypervelocity impacts. Now, what in the world, geologically, could cause a structure like this to be raised 5 to 7 miles above the moon and then persist for billions of years against this incessant bombardment? Is it conceivable that the moon that we think that we know, this moon, the moon of gently sculptured hills, the moon that was very carefully shown to us by NASA on television, and in the handful of pictures that have been released out of the literally millions of pictures taken of the moon, when was the last time you saw a new lunar picture? If you look at the textbooks, they keep recycling the same half-dozen frames. And they've literally got millions of pictures. Doesn't anybody wonder why we haven't seen a lot of pictures? Is it because the moon is all like this, dull and boring? Or is it because on some of those pictures, if you were to look in the corners or at the top, you'd see something like this? Obviously, the big question everybody wants to know is, well, what have you got in the way of corroborative evidence? Is this just a fluke of the picture? Is it just a spurious, something or other? Is it a dust speck, which you've enlarged, beyond all reasonable expectation? Or is it real? So to answer the question, what we're going to do now is we're going to go to the Apollo 10 series of photographs taken of the Okhotsk region in May of 1969, literally 25 years ago tonight, practically, within a few days. It's actually last week. But pretend I was here last week. A quarter of a century. And this is a map that is published in a very voluminous catalog that was issued by NASA, by the Manned Spacecraft Center in 1971 on the mission. We'll get back to the catalog in a minute because we found some other interesting things about that catalog. What I've done here is I've highlighted 3 frames, 4854, 4855, and 4856 that I'm going to show you. But before we do that, let me show you this. This is a brief geometry of the lighting by which we're going to analyze these. Physicists, when they look at a surface, are concerned with how the light is reflected from the surface back to the observer. You can have what's called backscatter, where the light basically comes right back in line with the light that hits the surface. You can have normal lighting, meaning at right angles, more or less, or you can have forward scatter, all right? Now, when you look at surfaces, and there's a familiar everyday experience that everybody has gone through that will illustrate beautifully why this geometry between light source, object, and viewer is crucial to figuring something out. You have company coming, and you haven't seen them in many, many years. You want to impress the hell out of them. And you have this wonderful house and this big veranda, and it's got all kinds of windows, and you're going to have a whole lunch outside on the veranda, and it overlooks the setting sun and the lake and the trees and all this. And as the company is driving up, you can see the sun beginning to come down past the awning, and you're looking out through the glass, and you realize you can't see anything because you forgot to wash the windows. This is an example of forward scattering. The sound of footsteps, rapidly heard in the background, is the sound of people scattering because they don't want to face the company coming up the walk to see the cruddy windows. The point is that the geometry, depending upon whether you're looking toward the light source or the light source is behind you, reflecting off the surface, will change dramatically your ability to see objects depending upon their size, their composition, their geometric structure, and several other parameters. So the scattering geometry is really crucial in any detailed analysis of these objects. This now is 4854. This is an Apollo photograph taken by an astronaut in the command module looking out the window with a handheld Hasselblad camera with an 80mm lens. There is a piece of 70mm film very high-resolution Ektar-based Kodachrome aerial reconnaissance film in the camera. This is the kind of film that was in the U-2s that Kennedy used to make the decision on the Cuban Missile Crisis, except in this case, you're orbiting 70 miles above the moon, twice the altitude of the lunar orbiter, and you're moving in this direction toward this terrain, actually at about an angle like about that, and in the forward window, out on the horizon, on the terminator, because this is now day and this is night, the moon is rotating toward you, so this is the dawn line. The light is creeping this way at about 20 miles per hour. You could walk and keep up with sunrise or sunset on the moon if you were in a spacesuit. This little guy right there is the cube on the tower. Now you'll notice that there are other weird things in this picture. In fact, there's a whole kind of fuzz along the horizon, and this area here is really fuzzy, and the fuzz is and is not connected with bright little islands. It appears to have a mind and life of its own. Now, first of all, what in the world is causing that? Obviously, we've overexposed this photograph a lot. We pushed the photo to the limit to find out what's down in the faint shadows. And what we're finding is that there is crud in the shadows that should not exist. Remember, there is no air, no water, no clouds, no hazes, nothing on the moon except a hard vacuum. So what is scattering this light in backscatter back toward the spacecraft orbiting toward it 70 miles above? As we get closer, this is now 4855, there's our little cube. Notice that these other guys have disappeared, and there's new guys that have appeared, all right? And there also appears to be a very faint geometric structure of regular horizontal and vertical lines. And keep in mind, this is not an electronic image originally. It is a handheld photograph. It is not a lunar orbiter picture. It is an Apollo image taken by an astronaut. And yet there appear to be some kind of regular geometry in this region where our plot, our geometric plot, says these Apollo photographs had to overlap the region of the tower and the cube. All right? Now here's 4856. Now here is our little guy again. Notice there are some straight spiky things. There is a strange arrangement of little... Now, you might say, okay, that's lint. These are lousy photographs. They're just bad photographs, all right? But lint does not possess a geometric pattern. What you want to look at here in the next montage is this. What we've done now is we've arrayed these three pictures. This is 48, 54, 55, 56. Notice this bright spot here, and here you can see that it's still there, and here it has gone away, all right? There is our little guy, the cube. You're getting closer. You're seeing a lot now of this regular geometry. As you're getting closer, you're seeing that there is a structure to this, a 3D structure. What we're seeing is a gridwork of light reflecting material above the moon. And remember, this is a completely different lighting geometry, time of day, technology, mission, and viewing angle from the similar grid-like structure we saw on the lunar orbiter photograph of the tower and the glass cube on top of it, taken from this direction, looking at about a 45-degree angle. So if this is the cube, and it's the one we think it is, then when we magnify it, we ought to be able to see, now what we've done is a false color here, and you can see that there is this spiky stuff which sticks up above the moon's surface, above the edge of the terminator, the sunrise line. And keep in mind the standard lunar model. Incessant meteor bombardment. Every shard, every long stringy thing should be beaten absolutely flat if there was anything there to begin with. So how come we have a surface that looks like prairie grass as opposed to the rounded, sculptured hills that is NASA's moon. This is the shot I call the Golden Arches, for obvious reasons. This is a fragment of something so big, so awesome, so stunning, that one time was so magnificent. And you can see that it's been beaten to hell. It's moth-eaten, there are holes, and above it, there is the cube. And this is obviously the base of the tower that we couldn't see from the other angle because the tower was down in front of the brightly overexposed surface that we had to overexpose to get the cube in the first place against the airless lunar sky. And as we go in, you can now see that this fuzz has detailed structure. Look at the geometry. Look at the layering. Look at the multiple levels. This is not lint. This is not scratches. This is a coherence of a geometry, a wondrous geometry which has been beaten to death by an incessant meteoric rain. How old must this be to be in this condition? And how can it be in any condition at all? Because obviously it can't exist. You're not seeing what your eyes are seeing. This is impossible in NASA's version of the moon. This is not real. This cannot be. And yet, if you look at it, you can see that there are planes of glass now. The edge that you saw on the other photograph is this edge rotated 45 degrees. We didn't have time, but by the time Dr. Mark Carlotta, who was one of our imaging specialists, and several others get finished compositing these views together with state-of-the-art 3D computer graphics technology, which is available almost now on any desktop, can you imagine what it will be like to fly 360 degrees around a glass tower rising 7 miles above the moon? The space program begins anew tonight. If this can be confirmed, if people can, through the internet, find the photographs in their own archives, in the photos that were freely given out by NASA 30 years ago, when the system was founded on the charter and was honest, the space program can begin anew. And we can stop marking time and waiting in the shallows while some timid bureaucrats wrestle with the dilemma of how to really tell us what they really found upon the moon. This is now the color stretch, so you can see, again, the internal geometry is extremely consistent and it's a cube. I mean, what can I say? You're looking at an incredible glassine cube. Now, this is what I call the hex. We went through several stages of processing, and the hardest part of this, and the reason why most of NASA's imaging people and scientists, I think, have not seen this, is because we are dealing with glass. And before you think I have completely flipped my noodle, I'm going to quote to you a very famous NASA study, soon to become more famous, where NASA itself has decided that when it someday gets around to going back to the moon and building a lunar base, guess what they think they're going to build it from? Lunar glass. It looks as if someone may have slightly beaten them to it. Now, what you can see here is symmetry, which I literally did not see until we did this processing about 48 hours ago. Look at this. Curve, curve, indentation, indentation, out, out, in, out, 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 in, and then these lines radiating like a huge cone. Remember that tripod this thing is standing on, like this? This looks like it was some kind of operations central, because it was very elaborate, it was very protected, and what we're seeing, again, in the model of constant, incessant, meteoric bombardment, is the inner protected parts of something that must have at one time been much bigger. How much bigger than 7 miles in the sky can you get? Now, before you think that we have lost everything, when I did the UN speech a few months ago, 2 years now, just before I walked on stage, someone called the Secretary General's office and claimed that a man from Mars was speaking downstairs. I was apprehensive that someone would call the university and say that a lunatic was coming on stage here tonight. But I guess they're not. Anyway, before you think that I am a lunatic, let me talk to you about Frank Lloyd Wright. In the 1930s, Frank Lloyd Wright proposed building a mile-high skyscraper built out of concrete and steel and glass. The 1930s, with 1930s state-of-the-art technology. Now, he was proposing doing this on planet Earth, where you have 1G, gravity, okay, where you have wind loading, thunderstorms, volcanoes, earthquakes, all kinds of vicissitudes for engineering. What could Frank Lloyd Wright have done given the airless lunar environment? No earthquakes, stable surface, no hurricanes, no wind loading, where nothing happens except the constant, incessant meteoric rain. This is going to become our mantra for tonight. Frank Lloyd Wright could easily have thrown a skyscraper 6 miles tall up into the lunar skies because gravity on the moon is 1/6 that of Earth. Well, if these guys were a little bit smarter and had access to something, a little bit tougher than concrete and steel. By the way, do you know why glass is one of the preferred materials on the moon in the NASA studies? Turns out that under airless anhydrous, that means waterless, lunar conditions, glass has the structural strength of steel. Just take away the water and the crystal defects go away, and there are some models that say that the stuff should be of the structural strength of steel. Well, if 60% of the surface of every silicate planet is silicon and oxygen, which produces quartz, which is basically sand, which is basically glass, you can see why this became the building material of choice. There's lots of raw materials. Now, are we talking about, kind of high-tech mohawks? No. We're talking about very sophisticated robotic technology, and we're talking about an energy source to process this material into endless miles of rods and beams and rebar and paneling and structural connections, and that implies hyperdimensional physics and hyperdimensional energy. In other words, if this is true, if this is in fact a real discovery of momentous proportions, artificial structures immensely old constructed by someone a long time ago on the moon, then it is in essence confirmation of the model developed through the monuments of Mars of hyperdimensional physics and energy and the use of those to process unlimited resources. In other words, if we go to the moon, if we go back to the moon, resume the space program that John Fitzgerald Kennedy envisioned over 30 years ago, the benefits to society, the ability to remake our planet by finding out how they did that, would more than make up for the trivial cost of going back, now that we know what's really there waiting for civilization. This is now 4856. Here's Bruce and Blagg. We've been looking down over here in this corner of the photo. That's where the cube hangs out. The lunar orbiter that took it was hovering right about here. Actually, it wasn't hovering. It was moving in that direction. And its sight line was here. Our sight line, as you can see, is here. So we have excellent cross-referencing, and all this weird structure is in this region. Well, it occurred to me that if we were to look north, if we were to follow along that northern track from down here where the tower appears to be northward, we would come across the landing site of the second set of missions that we sent to the moon before Apollo, the Surveyor series. So we did. This is a post-sunset shot taken by Surveyor 6 rather, from the surface of the moon, from the surface of Sinus Medii in 1967. What's this? Remember, the moon has no air. This photograph was taken an hour after lunar sunset. NASA says that this little mark is the resume mark on the faceplate of the scanning TV system. You can faintly see the scan lines, 600 scan lines going down like that at that angle. This is supposed to be the sun's corona exposed in this 30-second time exposure. This is the geometry, by the way, that we took directly from the JPL chart. Okay, here's the sun in this diagram. Here's the corona. This is from JPL Tech Report. There's the number 321262, published in 67, I believe. Frame number 7. There were 7 photographs taken in the sequence. We've only gotten our hands on one, and again, it's through Hawaii. It was my friend Joe Gill and his trusty little camera. All right? The sun's diameter is half a degree, 37 minutes of arc. Here are these weird lunar beads. Okay. The lunar beads were explained by NASA as basically sunlight being forward scattered by dust. Now, where was the dust? In their model, the dust was hovering several inches above the surface of the moon. What was holding up the dust? Electrostatic fields. This model has gone on and on and on for years. When the Apollo astronauts, particularly the Apollo 17 astronauts, landed at Taurus Littrow and did their drill cores and brought back the samples, and these were very carefully opened, and the column was examined to see how the particles would sort out. When you're panning for gold, the reason that panning works is because the heavy gold nuggets will sink to the bottom. Well, this is the inverse, where the light dust particles are supposed to float on these electrostatic fields caused by charging of sunlight at the terminator, the day-night dividing line on the moon as it goes around the moon at 20 miles an hour. What the astronauts found was there was no segregation of fine dust in the lunar core samples. The model doesn't work. So if you get rid of dust, what in the world can possibly explain this brilliant beading? This beading, by the way, is so bright that it has overexposed the Vidicon camera. It has exceeded the threshold latitude of the imaging system which took the picture. And then above it, you see this strange, well, now look closely. Do you begin to notice structure? Begin to notice parallel lines here? Little bright things, little cubicles. Look over here, all right? Very faintly over there. Let's go forward, all right? Look at this. Parallel, 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 parallel. And then these are the scan lines coming down, but there's other lines that go vertically. Little beaten, rounded cubicles arrayed in a neat geometry. And here's the other side. Look at these. And their lighting is consistent. If the lighting is coming from the sun and is lighting up some kind of structure, some gauzy gossamer grid that is lit only by the corona, this is not Arcturus, Antares. This is Alpha Scorpio, the brightest star in the summer sky, minus first magnitude, I believe. All right? Notice how bright, or dim, I should say, this stuff is compared to Antares. So it can't be lit by the sun direct, otherwise it would be blinding. But this is much brighter. This appears to be the inner corona, or maybe even the surface of the sun, beamed, refracted, lensed toward the camera by something right at the horizon. And then above this is this network of some kind of structure lit by the corona. And look at these parallel lines. Now it's moth-eaten, it's badly eroded, but there's enough left that you can actually see this regular spacing and this pattern of geometry, which should not, this is not in the corona. The corona doesn't have regular geometry. The corona is an expanding sphere of super hot gases at 2-3 million degrees Fahrenheit, leaving the sun at 400 to 500 miles per second. This appears to be on the moon and appears to be backlit, forward scattered light coming from some kind of grid photographed miles away by a surveyor after sunset. So this is our reconstruction of the physics of what you're seeing. Here's the photo from NASA. Here's surveyor, all right? It's looking toward the east, toward the west after sunset, okay? There's the sunset cutoff line. There's the sun shining down here 1 hour after sunset. You can actually calculate, because the moon rotates in a predictable fashion, how many degrees, how many miles, what the geometry should be. And there's a very complex geometry going on here, if we're right. The brilliant beads are caused by the ducting, the lensing along the surface by some kind of glass micro lenses into surveyor's camera. The stuff above is shielded from the corona or from the sun's surface and is lit only by the corona, which is about 1/1,000,000th as bright as the surface of the sun itself. So obviously it's going to be very, 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 very dim. If it's made of black stuff, it's going to be even dimmer, because it's going to be 1/10,000,000th if it reflects, let's say, 1%. This is what we think explains, and this is the geometry. You're sitting roughly here, looking in this direction, all right, after sunset. I'm sorry, looking over in this direction. Now, what we need to do is to look at another piece of technology, another mission, to get a comparative view. Because here was Apollo 10, whose lunar module came down to within 10 miles, and in the lunar module, out the windows, looking at the terminator between the day and night, it took 2 frames, 4789 and 4788. Now remember, this is going to be normal scattering. Sunlight coming in at a low angle, reflected up at the spacecraft, looking straight down on the dark terminator boundary. Sunlit landscape out here, lunar night down here, and this is sunrise. The sun is approaching from this direction, okay? Look what we have here. Now initially, when this was looked at, everybody thought, oh, this is just sunlight reflecting off the window of the lunar module. But as you look at the geometry, you realize, if you go in close, that can't be true, because there's detail, there's geometry, and the focal length of the 80mm lens on the Hasselblad can't have anything in focus closer than 50 feet. So how come, if these are scratches on the window, how come they're in focus? I mean, if they were really scratches, you wouldn't see anything. You'd see a featureless blur. In fact, if you enhance this, you can see that there is the same kind of grid structure, and the geometry is consistent with the surface surveyor shot, which is down on the surface looking underneath portions of this over here, all right? And this is like a sun glint that is backlit, like a spider web with little tiny bits of something reflective and refractive clinging to a dark substrate, which I have called, for want of a better term, the rebar. What I think we're seeing is a dark gridwork made out of some strong material on which is suspended glass panels or glass I-beams or glass structure of some very scalable proportion. And because of this incessant, constant bombardment by meteoric rain, what you're left with after untold millions of years is basically fragments of the glass on. Notice this pattern. You see there's a regular grid pattern like this? If we put this through a high-pass filter, which we've done, you really get spikes, and you can actually tell that there's a geometry there, because the signal-to-noise ratio is about 5:1. This is not down in the noise. This is an easily reproducible set of observations. This is Apollo 10, frames 4789 and 4788 from orbit 32. This is back to 4856 from orbit 32, and you're looking across the Surveyor site. Notice these funny things here. Originally, we thought those were hairs, that these were absolutely cruddy images. It turns out they're not. It turns out they're part of something hovering above the moon, between the spacecraft and the surface, 200 miles away, all right, because of the slant range here. And what this is, we'll show you shortly. It took us a long while to figure out the geometry. We now come to the point where I think we can answer one of the space age's most amazing mysteries. What happened to Surveyor 4? You'll notice here in the center of the moon, and on the right and on the left, there are a series of little dots. These dots represent landing sites of projected and actual missions. The Ranger crash landing spacecraft, the Russian soft landers and crash landers, the Surveyor landers, and of course the Apollo program itself. Clustered in the center, the only space where there were two spacecraft designated to land, and this is how the spacecraft landed. Surveyor took 3 days to come out from Earth. It coasted most of the way after liftoff. It then turned around, it fired a retro rocket, and ultimately landed softly on these three little landing legs on liquid-fueled vernier rockets from propellant stored on board in tanks. The retro rocket, the solid fuel retro rocket, would drop away at roughly 40,000 feet altitude. That's 8 miles at a burnout after the retro rocket had burned out. In 1967, in the middle of July of 1967, Surveyor 4 was targeted to land very close to the edge of Sinus Medi. Ukurt is up here, the tower is down here. The Surveyor structures that we've seen in that sunset shot are arrayed along here, and the terminator photography that Apollo conducted is located right around in here. All right, so it's all clustered in this little tiny area. Before all of this, in the middle of July, on the 16th of July, Surveyor 4 was to touch down, first soft landing in Sinus Medi on the moon. Why Sinus Medi? Because that was one of the Apollo landing sites that NASA was looking at. In fact, it turned out to be site selection number 3. Okay. A few seconds before it was to land, Surveyor 4 totally disappeared. In Aviation Week in Space Technology, which is the Bible of the aerospace industry, this little story appeared. It says, abrupt loss of all communications 2 seconds before burnout. That would put it at about 40,000 feet. No indication of trouble was received up to the last moment. It had been an absolutely perfect mission. Nothing had gone wrong. One of the curious things which has stuck in my memory, remember I was back in the museum. Actually, I was back in high school, traipsing back and forth to the museums during this period of time, was the instantaneous nature of the cutoff and the absence of any signal attenuation. NASA and the government and the DoD and whatever have had a lot of failures of spacecraft over the years. A lot of times, you've seen these old photographs where an Atlas rocket takes off and it rises up and then it begins to slowly and majestically do something which is the horror of every engineer. It begins to turn somersaults. It's not supposed to do that. And when it turns somersaults, the structural forces and whatever rip out paneling and separate tanks, and suddenly you get this blinding explosion. On the radios, on the telemetry link, the engineers can see the spacecraft die. The reason is simple. The speed of electrons and the speed of light are a lot faster than the speed of a chemical explosion. So as shrapnel is ripping the guts out of this exquisite jewel of handcrafted engineering, causing every engineer to weep with horror at his or her handiwork going up in flames, the telemetry people are watching the process of death on the oscilloscopes and on the chart recorders and whatever, because you can see it actually die. The shrapnel going through the radio cannot go fast enough before the echo, the attenuation, makes itself known, And it's from these readouts that engineers can reconstruct many times, provided they don't turn off the radio before things happen. They can that's an inside joke. You can reconstruct how the spacecraft died. That's why, by the way, you never turn off the radio. That's the second mantra. Well, Surveyor 4 didn't do any of that. 1 microsecond, Surveyor 4 was there. And the next microsecond, Surveyor 4 was not. And no one to this day has provided an explanation for what happened. Even the engineers at the time basically ruled out an explosion because they didn't see it, and they should have seen an explosion as it was destroying itself. The telemetry should have given them some indication from the instruments scattered around the spacecraft of a shock wave, a pressure wave, whatever. Instead, well, let me tell you what happened. And we don't need to move this slide because I'll tell you what's up there. This is the logo of Craig Warnke, who was one of our Mars mission members in California, who has been functioning as one of our intelligence agents on this little project. What Mark did was to, at my request, write to JPL, the Jet Propulsion Laboratory, and asked in a very nice way, with nice officialese, whatever happened to Surveyor 4? Could they please provide engineering data to fill in the historical gap caused by the absence of this spacecraft in all discernible records, et cetera, et cetera, et cetera. Before I show you what he got back as a reply, let me show you a couple of other letters that have been received from NASA and other agencies. This is a letter from a Mr. Hill, I believe, who is a proponent of the hollow Earth theory, namely that there are aliens living in the Earth and they're doing weird things and they're controlling the secret government. All right? Mr. Hill wrote to this particular gentleman at NASA, who is a reasonably high official, and received a very courteous response. Mr. Hill is very prolific, and he even wrote to the White House. You can't see it behind the video projector there, but he got a letter from D.D. Myers saying that Bill Clinton was very interested in Mr. Hill's thoughts about the hollow Earth and the secret government. Not only that, but this is the second letter that the White House sent to Mr. Hill, acknowledging that they had already received the first and that Mr. Clinton thinks that Americans should be well noted for their ideas. This is the letter that Craig Warnke got back from JPL. Now, what you see is his own letter. You see the JPL envelope, and at the bottom, highlighted in yellow, is the official NASA JPL response to Craig's request for information on Surveyor 4. The mission failed. Communication was lost during a retrorocket burn, period. Now, having dealt with a government that is first on the planet in the destruction of trees to generate letters on every conceivable subject, don't you find it a tad curious that JPL sent Craig's own letter back to him with a scribbled note and no address, no signature, no person, no nothing? NASA does not even have a record that this letter ever came to JPL. There's nothing in the file. No one will ever be able to find out that Craig Warnke on such and such a date wrote requesting information on Surveyor 4. Is it possible that someone is a tad sensitive about what happened to Surveyor 4? Would you like to know my theory as to what happened to Surveyor 4? You can see it right up there. At 6,000 miles per hour, it went splat. Backing down on the retro rocket, NASA had no idea that there was a grid, a structure, a tower, a mechanical object, a physical thing. And just before burnout, this poor little robot, without a clue, without radar to tell it what was coming up, it suddenly hit a wall. And what happens if you mechanically change the antenna by mechanically hitting it, you will change the beam pattern faster than the speed of light. It's called the scissors effect. Imagine an infinitely long scissors, and I close this end. The tips at some point on the scissors, the lateral swing will exceed the speed of light in the thought experiment. When I take the laser and I move it around the room, the tip is exceeding, the beam over there is exceeding the speed of light. Well, maybe not over there, but somewhere out there. The fact is that this spacecraft, I now believe, hit whatever larger structure this used to be part of. And when you look at the maps, when you actually reconstruct how it was coming in, it turns out that the flight path was very close to where we now think the tower exists. And when you inquire about Surveyor 4, you get your own letter back, the ultimate in recycling, with a handwritten note, with very terse, non-bureaucratic ease, the mission failed. Don't ask any more questions. So what's this? This is what I think Surveyor 4 ran into. I think there is, or was, a dome over Sinus Medae. And I think what we're seeing are fragments of the edge of this vast, multi-leveled, highly complex dome, which on Earth we already can see examples of. It's called the biosphere. And in the biosphere, what they have done is to take a trusswork made out of steel and hung glass panels and created a synthetic inside world, cut off, segregated, separated from the outside environment. Magnify this by 10, 15, 20 times. Not much for someone that knows a little bit more about engineering than we in the latter part of the 20th century do. And that's what I think Surveyor 4 had the misfortune of running into on the moon. And here, in another part of 4856, is the edges of the dome. This is now a very nicely enhanced sectional of Apollo frame 4856. Look at the cubical spacing, look at the multiple tier geometry, look at how it goes off beyond the terminator. You know, we're back to the golden arches. This is below the cube, which is way up here. How in the world has NASA been able to keep from telling us all these years? The answer to that is probably going to be the substance of many, many interesting congressional investigations. This is a joint session of the U.S. House of Representatives and the United States Senate. The date is May 25th, 1961. This is the President of the United States, John Fitzgerald Kennedy, laying out the vision of going to the moon. Here's what he said.
Time for this nation to take a clearly leading role in space achievement, which in many ways may hold the key to our future on Earth. I believe that this nation should commit itself to achieving the goal before this decade is out of landing a man on the moon and returning him safely to the Earth. No single space project in this period will be more impressive to mankind or more important for the long-range exploration of space, and none will be so difficult or expensive to accomplish.
7 years, a little over 7 years from the time that John Kennedy ushered in the space age with those words, astronauts were leaving regularly aboard the Saturn V, departing for, entering into, and looking down from lunar orbit. It is inconceivable to me that astronauts could not have seen some of what we've seen. And what we have been doing, in part, as this research has unfolded, is to go back to the original transcripts and try to figure out from the air to ground what it was that they may have said that would give us a clue. Because some of this stuff, if you look out the window with a monocular or a binocular, you should have seen beginning with Apollo 8.
Stand, we're going for TLS. Apollo 8 coming up on 20 seconds to ignition. Mark it, and you're looking very good. Roger. Transmission is coming to you approximately halfway between the moon and the Earth. We've had 31 hours, about 20 minutes into flight. We have about less than 40 hours left to go to the moon. Apollo 8 Houston, 1 minute to LOS, all systems go. All right, as you're going, command reset, tape recorder forward, low bit rate. Roger, safe journey, guys. We've got it. We've got it. Apollo 8 now in lunar orbit. Now approaching lunar sunrise, and for all the people back on Earth, the crew of Apollo 8 has a message that we would like to send to you. In the beginning, God created the heaven and the earth. Without form and void, and darkness was upon the face of the deep. And the Spirit of God moved upon the face of the waters. And God said, let there be light. And there was light. And God saw the light, that it was good. And God divided the light from the darkness.
Christmas, December 1968. For me, this is kind of poignant because that was my first mission with Walter Cronkite. That was my inaugural flight with CBS News. And I thought I knew the moon then. I thought I had lived every moment of history in the making. And I was wrong. The reason I was wrong is because something in the mechanism that was supposed to transmit the real information from the missions to the American people broke down. And it is up to us now to retrieve whatever that missing piece was, fix it, and go on as we were supposed to. A couple weeks ago, when Jackie Kennedy died, I was watching CNN putting this presentation together, thinking of this night. And I noticed that her biographer had a very interesting comment. She said that Jacqueline was only interested during the Kennedy years, during Camelot, in two political processes. One was the Alliance for Progress in South America, and the other was the space program. And I couldn't help but think of Queen Isabella and what had prompted John Kennedy to issue this challenge. We have all thought that it was Lyndon Johnson, who was the big-hearted, expansive Texan who galvanized us to go to the moon, beat the Russians, et cetera, et cetera. Is it possible that maybe we have someone else to thank for having this data? I don't have the answer, but I'm going to try to find out because I think it's important. Because what this will allow us to do is to return the process to the people that was begun by the Kennedy vision over 30 years ago, if we are correct. This now is a lunar orbiter frame. If you look to the north, you can see from the lunar orbiter position that 85M, 84M is this one, which has the tower and the shard down here. 85M, taken a few seconds later, looks to the northwest, all right? And what you see, if you look to the northwest, is this picture. This is 85M. Okhurt is up here, all right? Remember, this all started by looking at the triangle in Okhurt. Here is Chladni, just out of frame here. Here's a row of hills. Here's another hill, and there's some pounded, meteoric, battered debris in the center. Nothing to get anybody interested in this picture whatsoever. It's like a million other frames of the moon, right? Let's look again. You can see the outline of the wide angle, the M, and nested inside in these little red lines are the H's. There are 3 H photographs, 8 times the resolution of the wide angle M. There's Okhurt up there. There's Tri-Snecker. These are view angles, all right? Forget those lines for a minute. We'll get back to them. This now is a close-up showing the close-ups that are nested inside the wide angle in green. And as we look at one of them, you can see now the close-up of this little hill in the front. And lying out across in front of the camera as a wedge, you see this battered landscape. And there are craters and craters and craters. And again, nothing to write home about unless you begin to look really carefully. And then, if you're really sharp, you'll begin to notice that the craters are not single, they're double. And they're all aligned. Now, to make it easier, we can move in, all right? Here they are. Double, 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 double. There's a nice double one, all right? What causes double craters? Are we skipping stones off the surface so it goes boing, boing? And again, if we're dealing with boing, why aren't we getting boings at all angles? Why are they all aligned? Let's move in. The more you move in, the more you see these little double things tend to occur in pairs. They tend to be above and below each other. As you get closer and closer, you can see, as you begin to look at the structure, that instead of being a scooped out hole in a solid substrate, they have a microstructure. You can see here's one and here's another. In fact, there's an ellipse that runs around both with a kind of a dividing line in between. All right? It's almost as if, okay, here, let's get closer, all right? Now notice the shards, notice the layering, notice the vertical spacing. There is an intense geometry about these that defies conventional lunar explanation. The smallest thing you're seeing on the scale of these photographs, now there's a real good one, all right? And they're all aligned. They're tilted about 40 degrees off the north-south line. Row after row after row after row after row. And because, I'm going to leap to the end of this, we're dealing with a glass material. You're looking through levels and layers. Here's one end, and here's the other end. Double. And they have structure that goes down in between, and you can actually see what look to be like walls. Now look at this thing up here, all right? Hanging. And before you say that's a hair, this is an Earth photograph by way of comparison. The problem with looking at ruins is unless you're good at geometry and know how to abstract and look at the geometric underlying pattern, not looking for the Chrysler Building, you're not going to see the obvious. This is Dresden after the horrible firebombing in World War II. This is a close-up of Dresden, all right? This is a close-up of one of these stringers. Notice the similar pattern. Notice the verticals, the horizontals, the crossbar, the regular size of each of these little vesicles, whatever they are. There's a wall sticking out. Notice this parallel pattern. Notice this one above it. Notice this. You're looking at a 3D cross-section of three basic geometries, a hexagonal 3D geometry as near as we can dope it out. Robert Firtek, one of our architects, and I have been trying to figure out now for several months the 3D pattern. Look at this little thing up here. This is another little tiny shard, and this is fairly small. This is probably on the order of 20, 30 feet tall, given that the best resolution on this picture, and these are the ruins again, on Earth. Compare this with this, all right? Again, notice the pattern. Look for the mega pattern, all right? Don't try to recognize a specific building. Look at the regular geometry of the pattern. The most amazing regular geometry is when you have edges, bright edges, refracting sunlight, which have absolutely precise geometric patterns like this. And look at here. You can see how it's made of transparent material. So you have edges hanging in front of other edges. And you can see, I mean, it's no wonder that most of the agency completely overlooked this, because this boggles the mind. This transcends the belief of anybody dealing with lunar geology, lunar structure. They're looking for volcanoes and craters and secondaries and, marginal mare emplacements and wrinkle ridges. They're not looking for shards of glass. This is the moon they think exists. This is the moon that has to exist. So under this kind of bombardment, again, the standard model, how can you have anything like that? Look at how delicate, look at how fragile. This is crystal. This is a crystalline material which has shards. This is on the order of a reasonable building on Earth, except it's hanging, obviously, over mid-space, over a chasm of some kind, created by a major impact. What we know about the moon is that the moon is composed of an Earth side and a far side, and the two sides are not the same. There definitely appears to be a side that we can see that is plain, mottled, dark, with interleaved terrain. These are geological maps made by taking multispectral data and superimposing it over the normal photographs. The highlands, the bright material on the Earth side, accounts for maybe 30–40%. On the far side, it accounts for 80–90%. There appears to be a real disparity between the side we can see and the side we can't see. What is the reason for that disparity? That is a question which has been lingering for age after age after age in the minds of everyone. Well, we're on the verge of getting an answer. The Apollo missions and the rocks they brought back, we now believe will furnish us the chemical clues to begin to come up with an answer. And it turns out that that answer is in the form of data from the Apollo 8 mission. The Apollo 8 mission, as I said before, flew to the moon in December of 1968, made 10 orbits and came home. The most amazing Christmas present the world has seen then and has seen since. One of the benefits of talking about this presentation has been that as I've been on the radio coast to coast a 3 nights ago, one of the former NASA employees that heard me put this catalog, an original Apollo 8 catalog, in the Federal Express system and got it to me within 24 hours so I could look through it. There's an SP number up there, which I think is 207, so you can go back and get it yourself if you can find one somewhere in the world. The reason it's important is because it contains all of the background data on the films and lenses and technology whereby these photographs were acquired. Table after table of reciprocity of the film, the focal length of the lenses, shutter speeds, light reflectance, transmission in infrared, visible, ultraviolet. And then in the back it contains photograph after photograph taken during the Apollo 8 mission. It is a treasure trove. It's about that thick. It's everything you ever wanted to know about Apollo 8 and didn't know who to ask. It has become a benchmark, and I'll show you why. For other missions, for like this, Apollo 12, remember Surveyor 3 that landed over in Oceanus Procellarum, visited by Apollo 12? Well, this is the cover photograph of a report on the analysis of the Surveyor material returned to Earth. Unlike Surveyor 4, when you inquire about this Surveyor spacecraft, you get decent data for some reason. And inside, in the back, there are photographs, photograph after photograph, very nicely portrayed with the frame number, so if you want this photograph, you can order that frame number and you'll get it. Craig Wantke, who has become our kind of lunar resource in terms of early warning data, told me months ago, a year and a half ago when I began this, he says, Dick, he says, I have the original Apollo 10 catalog. And so I had him send to me samples of what was in the catalog. And this is what I got. Here we have a photograph, blank. Here's one overexposed. This is dark. This is way underexposed. This is dark, overexposed, way underexposed, blank, underexposed, underexposed, Well, this one's all right. Out of 1, 2, 3, 4, 5, 6, 7, 8, 1 out of 12. And that's only one page. This goes on for page after page after page. Now, do you mean to tell me between 1969, when Apollo 8 came out with its catalog, and 1971, when the Apollo 10 catalog was issued, that catalog production technology in the United States took a terrible drop? That somehow NASA had the wrong contractor? That people were basically hiring ghost employees? I mean, no one would ever do that in the federal government, would they? You're up on it, okay. So what we did is, I mean, I'm always intrigued by the weird stuff. Show me, thank you, show me an anomaly, and I wonder what's behind the anomaly. It's like, I should have been Monty Hall. You know, I'll take door number 3. Well, this really intrigued me. So what did I do? I ordered the blank photograph. And guess what? There it is. Now, this is kind of interesting. If you look on this map, you will see every photograph taken by Apollo 10 of the Okhurt region, okay? Well, almost. You won't see this one. It's blank in the photo section. It doesn't appear on the maps, and yet there it is. Now, how did we acquire a non-existent picture? Well, in the wake of Mars Observer, there are people who are sending us data. Now, this is 4822. This is perhaps the most important photo that I'm going to talk to you about tonight. So mark that down. Okay, this is, Okhurt is over on the left here. There's an interesting series of linear features. They're very large. We're talking 10, 20, 30 miles along here, okay? This is a very large amount of terrain. Over here, if you look carefully, you'll begin to see a kind of a regular pattern. This is the part that Dr. Cornett calls Los Angeles, because it turns out to have a grid-like pattern. Dr. Cornett is a geologist. He is from Red Bank, New Jersey. He was with Lamont Doherty, Columbia University. And when I showed him this stuff as a geologist, can I say freaked out? Can I say that, Bruce? This really bothers him because this should not be on the moon. This is as if you were looking at Hiroshima or Nagasaki after the war. The streets are there, the foundations are there, the buildings are gone, but the pattern remains. Now, let's look a little more closely. This is a very interesting photo. For one thing, the light fall off as you go from here over to here is really, really weird. Remember, there's an airless vacuum. What in the world would cause the fall off from here to here? The phase angle is about 30 degrees, all right? The sun is coming in from the right. It's about normal lighting. So why should the photo get really dark over there? Well, let's look closer, all right? Now we've got this stuff again, and let's look really close. And this, of course, I think is why they don't want you to see this, because this now, look at all these faint lines. Look at how they're oriented, parallel. They're not caused by photo developing. This is the Hyginus rill back here. Look at how dark the surface becomes. Look at how this stuff is uniformly scattered, except it's got a coherence. And then look at this little guy. And as we zoom in, you'll see why this photograph is blanked out in the catalog. This is a castle floating 30 miles above the moon. Now, it's not a real castle, but it certainly looks like a castle. It looks like that one in Germany that they patterned, Sleeping Beauty's castle in Disney after. This is an absolutely stunning object. This should not exist. As one of our geologists said, hell, he said, Dick, when they looked out the windows, they should have been able to see the pigeons on that one as it went by. If you look at this carefully, and we've done a preliminary analysis because we literally just found this, all right? you can see that every part of the lighting is consistent with the sun coming in, a 3D glass crystalline structure, a remnant hanging on the rebar, the invisible dark substrate of the dome over Sinus Medii. And if you look really closely, notice how it's glowing. Notice how proportioned, how the shadows are falling correctly. When our photographic expert, Carrie Clark, at High Definition Image in New York, looked at this, she absolutely freaked out. Her first reaction was that can't be real, you know, and she actually looked at the print. Now let me tell you how I got this. This came as part of a set of 16 by 20 prints by way of one of my NASA contacts at Greenbelt, Maryland. We do not have the negative. When we ordered the negative, this and all its companions have vanished. However, we found other things which demonstrate to us that this is real. In fact, what I'm going to be able to show you is there's more than one 4822, and I can prove it here tonight. Okay, this is now the best close-up. Notice that these things appear to be, what do they call this, trapezoidal, okay? And there's a consistency again in the lighting. This is conical. There's a little dome here, all right? This is absolutely amazing to exist. Look at that. Believe me, when I saw this, I said there is no way that the astronauts could not have seen this. So how have we been fed, given the lie that nothing unusual was seen orbiting over the moon? Look, this part down here, if you look very carefully, you can see there's a faint white line that runs and connects these two, all right? This is a fragment like this, except most of the rest of this has been blown away by meteorite activity. This thing has, there's no way to judge how big it is because we don't know how far away it is. What we do know is that it's part of a contiguous set of objects hung in a 3D matrix. Look at this one. Now this looks like a close-up of some of the rebar we saw on the southern part of Sinus Medii. This one is this guy up here. All right, what I want to show you here is if you look very carefully, you can see it's lit by sunlight here. Sun is coming in this way. There's the shadows. Then it disappears for a while, and it comes back out because there is an obscuring medium between the camera and the object. This stuff is in planes and in layering and in 3D, and you're looking edgewise through, I believe, the curving upper parts of this dome. Now, I'm calling it a dome. In fact, I think it's a hexagonal truss. I don't think it looks like a dome in the sense of being a smooth, polished dome. I think it was built of a complex geometry. And what did Bucky Fuller finally show us? That a truss work, a trapezoidal, tetrahedral geometry, hexagonal geometry is the strongest pound for pound of anything you can build. Okay. Now, look at this one. You see the individual indentations? The important thing is that this does not live by itself. If you only had one object, you would say there's no way that it can be real. But the fact that you have consistent lighting, that you have surrounding objects also lit with consistent lighting, and there is material linking these objects in a matrix, that's what gives us confidence that this, in fact, is part of fragmentary debris, the bits clinging to the spider web, to the grid, to the rebar of the former pristine structure. And the only logical reason for something being this high is either a dome or spires sticking up out of a dome. Now here again we have a highly notice these faint radial lines. This is very important. If we can get one other frame where we can pull this stuff up, we can do stereo and actually get the distance to these things. But unless we put a concerted political effort, I mean, I think we got this frame by accident. I don't think this was intended for us to get, because when we, went in to get negatives, we found some very strange fishiness, like this, all right? This is now an overexposed version of 4822, all right? Here's our little castle. This is a crater called Menelaus back toward the horizon, all right? Maybe, well, what, you're about 500 miles away because you're twice the altitude, and the hypotenuse is longer, all right? Here's Okhurt over here. Notice there's stuff in the sky, all right? Now, this is close-up Menelaus. Now this is enhanced looking toward Menelaus. Look at all this stuff lying above the sight line. Look at how it gets denser as you go down and thins out as you go up. And notice again that there is an internal consistency to the geometry, and there are parallel lines cross-bracing. See that one there? All right. Now focus on this up here. All right. This is, I think, the apex of the dome. You see this here? This is a photographic defect. All right. That's not real. All right. But this is, and notice this. Notice this truss. It almost looks like a bridge beam. All right. You see this coherence with all these little bits and pieces scattered around it? This, I think, is the uppermost part of the dome. And we found another one of these in much better condition about a third of the way around the planet. This, of course, is Biosphere 2. This, Biosphere 1. I mean, this is a lot older than this, but the model is the same. I mean, look, the purpose of these guys' experiment, funded by Mr. Bass out there in the Arizona desert, is to explore the possibility that someday we will take men and women and we will go where you will need completely contained environments. Paulo Soleri called them arcologies, architectural ecologies. Well, here we seem to have an example that somebody's beat us to it. Now that, of course, is mind-boggling enough, but the correlative mind-boggling thing is that the geometry of the grid turns out to be the same. Remember, common engineering, common solution to common problems. You simply scale this up by some factor, and you've got yourself what we're seeing on this lunar data, except it should not exist above the moon. Now, here's another weirdness. This really bothers us at a political level because this is 4822. All right, look very carefully. Look at this little guy right over here, and look over here. All right, there's Menelaus. There's our castle. All right, there's the photo degradation, the strange light effect that goes down. Let me give you a possible explanation for that weird effect. If the grid is acting like Venetian blinds, you've got physical members all in parallel. Over here, you're looking through the blinds, the rebar, at an angle that allows light to penetrate up. Over here, you change that angle by almost 35 degrees, and what happens? It gets darker and darker and darker because it's like closing a Luvalor blind. It's a mechanical shutter effect. Nothing like this should really be on the lunar surface unless there's something obscuring your view, which is created by a geometric effect caused by a mechanical blockage of the light reaching you from the surface to the camera. And again, this is a testable model. All right, now what is wrong with this picture? This is one produced. This is 4822 from the National Space Science Data Center. For one thing, this guy is missing. They're all missing. And for another thing, if you look really closely down here, you'll see that there's a change. A brilliant specular reflection, which is not present on our original 4822. Now, how did that get there? I mean, you can't have a picture changing itself between the copying process. If they airbrushed out the other stuff and gave us merely a photo without the good stuff on it, how did that appear? Answer: you're looking at a specular reflection. This now is part of this complex. This is now in close-up. Look at this. Yeah, look at this. Now, notice the pattern. Notice this grid pattern, all right? This whole thing is a glass structure on the surface of the moon on the scale of a mountain. You are looking at a fragment of a destroyed arcology at the edge of Sinus Medi, just to the west of Okhurt. And remember, the reason we're looking in this region is because from 250,000 miles away in the center of the lunar disk, in the middle of that crater, there is an eerie equilateral triangle that should not be there. Indiana Jones was right. X does not mark the spot. Now, as you look carefully, you'll see that this brilliant reflection has, again, geometry. This has got to be a planar surface of very large dimensions, which as the moon rotated and the spacecraft was moving, the angles all got just right, and you had this sudden piercing reflection. Now let me show you the geometry, because this is very important to decoding. Oh, this, by the way, is another 4822. All right? Where's the reflection? This was our second order from the National Space Science Data Center. We've been keeping very careful records. We've been getting photographs from Houston. We've been getting photographs from NSDC. We've gotten some from Hawaii, a couple from private archives. We had one filched from the administrator's office in Washington and NASA headquarters. I'm not going to tell you who did that. And what's interesting is the same frame numbers, things keep changing. Now that shouldn't be happening. Again, look at this pattern. If you look carefully, you'll see that the pattern remains the same, all right, in terms of the megastructure, but in terms of that reflection, look, by the way, at what's going on up there in that weird little thing. I call that, by the way, the Crystal Palace, because it literally is hanging in midair, another mini version of the other guy, but this one is much closer. This one is only a mile above the surface. All right, this is now back to the reflection shot. Look at this. Look at this geometry. This is a whole apartment complex. See the layering? Now, when you photograph different angles of a surface, you should get the same surface if the angle changes a degree or two. And as the astronauts are moving at about 1.5 miles per second, you know, depending upon the interval of picture, pause, picture, the angle should not change all that much. But what's happening here is the surface is changing wildly. The reason has to do with the nature of optics, the nature of physics, the fact that as you're moving, this now is a false color, and you can really see the planes and the multiple geometries of the reflection in front of the Crystal Palace. This thing is a 3D glass structure, and you're looking deep into it through not only what's ever between you and the spacecraft, but also between what is ever between the surface and deep inside. And the detailed photometric is going to blow us away when we get the numbers. This now is back to one of our 4822s. Look at these regular. Look at it as regular. All right, there's a huge cavity in here. You can see stuff way down. This is enormous. This thing is a good 10, 15 miles, all right, with absolute regular crystalline geometry battered to hell by billions of years of incessant meteoric rain. Now look at this detailed structure. Look at these shards. How can these shards have persisted under any process, under this constant bombardment, unless, and this is crucial, if you begin with a fragile crystalline structure and you begin to erode it, Bruce will attest, my resident geologist here, one of several, that the structure will erode back along the previous structure. In other words, a hexagonal lattice-like structure will retain its hexagonal lattice-like structure. It just will get smaller and smaller and smaller. It's like a sugar cube melting in water. And finally, this is now close-up of the Crystal Palace, the shards sticking up in front of it. Look at the planes. Look at the geometry. They're going to say on my tombstone, he died for geometry. This is a dome. This is part of a dome. You can see the translucence and then this stuff embedded inside, beaten to hell. This is now the details of the glass shards. Look at this stuff. This is not the moon we have been given for over 30 years. This is something else, and this frame doesn't even show on this portrayal of frames. Now this is the reflection geometry. Here's the sun, and you get a cone of light from a planar surface. If the same size cone is farther back, it takes you longer to go through it. What we can do is to look at these photographs and watch the reflections popping in and out in the overall picture. And this stuff is filled with glass-like specular reflections. What do we do about this, and how do we get our space program back? As you can see, the Clementine mission is a very mysterious mission. It was launched into lunar orbit in January of this year, literally on the evening of the President's State of the Union address on January 25th. It took a month to get to the moon. They placed it in polar orbit. Mission run by the Pentagon, by the Ballistic Missile Defense Organization, spent 2 months mapping the moon at resolution down to, we are told, something on the order of 100 meters, that's 300 feet. At that scale, unless you know what you're looking for and looking at, you're not going to see the things that I've been showing you tonight. The photographs that I've been showing are on the order of resolution of 10 meters down to 1 meter for the close-ups looking over Kurt from 85M on the high resolution. This is a Clementine photograph of the North Polar region. It was taken from 1,500 miles away. When I asked some of the Clementine folks why they were not going down to lunar orbit altitude, they told me they could not because of orbit instabilities. Now, that's not the reason. But given what we have just seen, given the fact that there are debris clouds hanging, suspended, and visible at some lighting in the skies above the lunar surface, what else could they say? Well, you can't go any lower, Dick, because we'll get clobbered? That would kind of give the game away. I mean, I am amazed that we did not kill one group of the Apollo astronauts. Looking back now, looking at how close this stuff is, how much of it there is, I could go on for hours with the data we've acquired, and we will in other forums. But what we have found is, for instance, transcripts where the astronauts literally report that they have seen veilings and gauzy material overlying the lunar surface, and they make comments like, it looks as if it's suspended above it, but of course that can't be. And in other references, other papers where they were looking at dim light phenomena before dawn and after sunset, they report just before sunrise incredible, bright, very parallel geometric rays of light extending up from the horizon above the spacecraft. That means in some sections, this rebar, this grid, has to extend above the orbit of the Apollo spacecraft. And it's only because it's got lots and lots of holes, and these photographs are looking through literally tens of thousands of cubic miles and making it appear as if it's very dense, that we're able to see some of this stuff at all, because if it's a day, it's very, very old and almost gone. Now, Clementine is important because during the 2-month Clementine mission, as opposed to Lunar Orbiter, which took film, as opposed to Surveyor, which sat at one spot on the surface and took TV, as opposed to Apollo that took handheld photographs, Clementine returned 1.5 million electronic, state-of-the-art CCD images of the moon in every spectral band from ultraviolet to infrared. Unfortunately, those photographs do not come under the NASA charter. Unfortunately, if they so chose, they could keep every single frame from us. We are now told that we are not going to get to see these images until late fall or maybe by Christmas. If that's true, can you imagine what you could do with a supercomputer working on these frames day and night to gently remove any of the offending material, so we preserve the illusion that the moon that Clementine saw is the same moon that Apollo saw, is the same moon that Surveyor saw, is the same moon that Galileo saw. We must ask demand through the constitutional, legislative, congressional process and through the administration, through members of the Clinton administration to whom we are going to show this, we must demand immediate full access to all of the Clementine imagery. That's the first thing. Around Clementine, there is something of a problem, because when Clementine finished orbiting the moon, one of the things that the Pentagon tried to do, even though the mission had been dubbed as a moon asteroid mission, was they attempted to kill the mission financially. The day the spacecraft left orbit, the head of BMDO, General O'Neill, tried to close down the Clementine operation for want of $3.2 million. Senators and congressmen came to the rescue, and on Wednesday morning, the New York Times reported that the money had been reprogrammed from some other project, and in fact, they had put it back in, and the mission was going to go on, leave lunar orbit. It was going to successfully loop around the Earth once, and then back out within 7,800 miles of the moon and on to a rendezvous with Geographos in August of this year. Then, a couple days later, this AP story appeared on Saturday morning. Saturday is a bad day for spacecraft. Mars Observer disappeared on a Saturday. On Saturday morning, 3 or 4 days after O'Neill had tried to kill Clementine financially and was forced to rescind the order by Congress, the onboard computer mistakenly activated several thrusters, burning up much of the fuel and basically killing the mission. The spacecraft is now a useless piece of junk spinning at 80 RPM between Earth and the moon. Now, all of this would not be relevant, except without those photographs, we are not going to be able to find out what it was that Clementine verified of our hypothesis. And if there is any doubt in your minds now that something is going on, that something is being withheld, I would like to refer you back to how we began this presentation, which is the Brookings document. Because on page 216, it says, continuing studies are recommended to determine emotional and intellectual understanding and attitude, and successive alterations of them, if any, regarding the possibility and consequences of discovering intelligent extraterrestrial life. To which my question is, were those studies ever conducted? And if they were, what did they find? Did they find that we would freak out, that we would keel over, that we will disintegrate if we were to find officially that all of this was correct? But the capper for the Brookings document, which is my reason for apprehension about what's going to happen to the NASA archives, as well as the Clementine imagery, is in this page when it goes on to say that questions one might wish to answer by such studies should include how might such information, under what circumstances, be presented to or withheld from the public? For what ends? And then one might the role of the discovering scientists and other decision makers regarding release of the fact of discovery. This again is a document commissioned by NASA in the late 50s, early 60s on what to do if and when material, information such as I presented tonight, were to become available to our scientific process. In the footnotes to Brookings, it says the fundamentalist and anti-science sects are growing apace around the world. Remember, this is 59. And as missionary enterprises may have schools and a good deal of literature attached to them. One of the important things is that where they are active, they appeal to the illiterate and semi-illiterate, including as missions the preachers as well as the congregation, and can pile up very influential followings in terms of numbers. For them, the discovery of other life, rather than any other space product, would be electrifying. So there you have it. In 1959, fear of religious fanaticism as a reason for withholding knowledge that the human race is not alone. Now, the world that Brookings forecast 30 years ago is the world we now inhabit in 1994. What are the major terrorists and trouble spots on Earth fueled by? What is Bosnia being shattered in front of our television screens every night by? What almost shattered the World Trade Towers in New York? Religious, fanatical fundamentalism. Is that the reason why NASA for 30 years has dared not tell us what it found right next door? And finally, there is perhaps the ironic capper that the document says that it is perhaps interesting to note that of all the groups, it said that scientists and engineers might be the most devastated by the discovery of relatively superior creatures. And who, might we ask, has been running NASA for the last 30 years but scientists and engineers? Ladies and gentlemen, I put it to you very simply that all we can do is to pray that out of the millions of pictures acquired by NASA and the thousands that were distributed freely in the early days and years when it was honest, some people have retained in their personal and library and museum archives copies and samples and duplicates of that which I've shown you tonight. And it is incumbent, it is mandated, it is demanded that we go to those people and find those frames and duplicate what we have done and find out why we have been lied to all these years. This is the Apollo mapping camera. The latter Apollos, from Apollo 15 through 17, carried a 24-inch camera that took photographs from horizon to horizon and then very high-resolution strips of photography all the way around the moon. Almost none of that photography has been examined. The photographs and the catalogs literally live 1,000 miles apart. The people who have the catalogs don't ever see the frames. The people who have the frames can never see the catalogs. That's interesting. What we're now going to do as the next phase of this investigation is to begin to see it is absolutely crucial that we figure this out. This is, of course, a photograph, another Galileo montage taken by the successful Galileo swing-by in 1991 en route to Jupiter of the spacecraft photographing Earth from several million miles away. While this photograph was being taken, down on Earth, normal things were occurring. Sunrise, moonrise, dawn, the Earth spinning from night into day as it has been doing for thousands, millions, billions of years. And in a small place in England, Salisbury Plain, a stone monument exists that sees another dawn. Like countless dawns before, huge rocks piled up in an enigmatic circle with a semicircle inside. It is this object which people like Jerry Hawkins and others have now proven was a monument to Selene, a monument to mark the passage and the timing of the moon between the standing stones. It is, of course, modern science which allows us to look deeper at this monument, and one of our team, Carl Monk, has discovered that some of the math and geometry that we have discovered at Cydonia also appears in the layout of this structure located on the Salisbury Plain in England. The specific geometry repeats in the standing stones, in the layout, in the dimensions, in the radius, in the very form of the monument itself. 1,000 years ahead in time, as this planet has been spinning around the sun and spinning on its axis, a whole new generation of moon watchers has arisen. Generation of moon watchers who can build cities, lay out carpets of steel and glass and lighting, travel freely from continent to continent, and briefly fling small slivers of technology 250,000 miles away into space to travel between Earth and Moon. That culture now stands poised between a past which, if the monuments of the Moon are as interesting as the monuments of Mars, must stretch now billions of years backward.